Video is going to give a quick overview of what a system of linear equations is, and then show you how to convert that system into a matrix format. So in this case here, I've given you an example of a system of equations, and there are three equations in this system, and there are three variables in this system. And so we would usually call this a 3 by 3 system of equations. This is usually the level that we see in a lot of undergraduate classes, because it's enough that it takes a little bit of work and you need to show that you understand the process in order to be able to handle 3 by 3 systems, and it doesn't take too long to solve the problems, whereas if it was like a 5 by 5 or a 6 by 6, it just takes a really long time. So 3 by 3s are usually kind of the sweet spot where you can learn the techniques without it being insanely long to do the problem. Okay, now when you have a system of linear equations, and these are all linear, you see all of the variables are only to the first power, right? In terms of algebra, this means it's degree 1 everywhere. So when I have a system of linear equations, it turns out there are only 3 possibilities when you're solving it. And I can draw these in 2 dimensions easiest. I'm not going to try to draw what happens in 3 dimensions here. But in 2 dimensions, you could have your 2 lines here, and they could be going along, and they can cross exactly 1 time. Well, in this case here, we call the system consistent because there's at least one answer. We say they're independent because the 2 lines are not the same. Now, we are going to learn more about independent later, but for now, that's what we're seeing. And there's going to be exactly one solution to the problem. This is what we'd consider the normal scenario, the one you're going to expect to see most often. The next one is going to be one that we are not going to see as often, but it does happen. And that's where you have parallel lines. And if they're parallel lines, you're going to have no solutions. And the corresponding words is inconsistent because there's no answer. However, they are still independent because they are not the same line. And that probably clues you into what the third possibility is. The third possibility is when the 2 lines are in fact the same line, they overlap here. And in that case, there are going to be infinitely many solutions. And that's going to be an important concept in a later video, but for now at least it's not going to happen so much. We call those consistent because there is at least one answer to the problem, but they are now dependent lines. Now in algebra class, you learn how to solve these by adding equations together and playing around. There's something called substitution, elimination. Sometimes they'll even have you graph them to solve them. So there are a variety of methods to do it, but in this class what we're focusing on is solving them using matrices. And so let me show you how we're going to turn this. If we want to turn the system equations into a matrix problem, so a matrix is going to have these square brackets here. And basically what you do is once you have the equations in a nice systematic fashion here, with the x, y's, and z's all lined up, you're basically just going to take those same things and remove the variables and only write the coefficients. So you see I'm taking my system of equations there and just only copying the numbers, the coefficients of everything. I'm leaving the variables off, and what we're going to do is we're going to do manipulations with this matrix here, and that's going to allow us to find the answer. And this is going to be, in particular, it's going to be called a 3 by 4 matrix because there are 3 rows and 4 columns. And we have another name for this. This is called the Augmented Matrix. So the Augmented Matrix is when you include the right-hand side of the equations here. And if you don't include the right-hand side of the equations, and you only include the numbers on the left, well, this is called the coefficient matrix. And there are times when you'd want the coefficient matrix And there are times when you'd want the augmented matrix. It depends on what you're trying to do. And so for this video, we're just kind of introducing these concepts here. And then the other videos we'll learn what we can do with these.